Hello and welcome to day 17 of 5 steps to a 5, or 5 days to a 5, 5 minutes to a 5, 5 to a 5, day 17. So we have here a question that is a graph, and before we read the question and get confused or upset by it, we are going to apply our process of understanding what it shows before we do anything at all. And that process, whenever we see a graph, is Oixirga, Oixirga. We look at the origin, there are no numbers, and so we assume it's 0, 0. That's the best we can do. The y-axis is velocity without numbers or units, so it's going to be conceptual. X-axis is time without numbers or units. The intercept, looks like it's the origin, so that means at time 0, the velocity was 0. What we can read from the graph is going to be anything to do with the instantaneous velocity or the time. The gradient or the slope is delta v over delta t. It's dividing the axes, and we should recognize that as the acceleration. If we didn't, we could put in the units and see it's meters per second or meters per second squared, and that would clue us into it being acceleration. And we can see that the slope is changing here. And the area is multiplying the axes, v times t, and the units on that are meters per second times seconds. So the area is the displacement. So what we're looking for now is the positive direction is to the right. That's great. During the motion represented, so let's analyze first what's happening to the velocity. The velocity is increasing and seems to level out at a value and maybe constant at the end. The acceleration is given by the slope, and so we draw a tangent there, and a tangent there, and a tangent there, and a tangent there. We can see that the slope in all of these cases is positive, but it has a decreasing magnitude. So we might say this is +4, and this is +3, and this is +2, and this is plus 0.5, or it's becoming 0. It's certainly not negative at that point. So the magnitude is decreasing. Thus, the acceleration starts out at a maximum and decreases to 0 by the end. And then the area, delta x, if we look at this, as time goes by, the area keeps increasing. And even at the end, the area keeps getting larger. And so that means the displacement keeps getting larger, and it's positive. So this object is moving to the right, the positive direction, and it is not slowing down. It's just not speeding up as quickly. It speeds up, the velocity increases, and then it stays steady all the while moving in the positive direction. Okay. Now we're finally able to get to the question. And remember, the Princeton Review even says that 80% of the time is in preparing an answer. It's not the answering itself. So if you have 10 minutes for this question, 8 of those 10 minutes should be dedicated to the work you do before you even start writing. It should only be the last 2 minutes. So during the motion, the magnitude of the acceleration increasing, decreasing, or remaining constant. Justify your answer. Okay. So what we're going to say is the acceleration, since we've already done this work, the acceleration is decreasing. And the reasons for that is it starts out, the acceleration is the slope. The slope is steepest at the beginning, and it becomes less steep until the slope is 0 at the end. Aha! So now we have our justification for our answer. So now we'll set to writing the answer to this, or writing a potential answer to this. And so we'll say, the magnitude of the object's acceleration during the interval decreases from its maximum at the beginning times 0 to approximately 0 at the end. So if we go back to our thing here, so we said it's decreasing, okay? Oh, we haven't said anything about it being the slope. So the question is, where's the best place to do this? And one of the simplest places for us to do this with the fewest words is right at the beginning. The magnitude of the object's acceleration, the slope of the graph, or just the slope, decreases from its maximum at the beginning, t0, to approximately 0 at the end. And we could say that because the slope decreases from a max at t equals 0 to 0 at the end. And again, we could work to polish this even more. And remember, our focus needs to be to make it as easy as possible for the rater to find the answer as quickly as possible. The longer we take, the more and the harder the rater has to work to find the answer, the less likely it is you are going to get points. Raters are trained to go as quickly as possible.